Imagine looking up at the night sky, and something is wrong. The stars are still there. The Earth is still turning. Your city is completely normal. But the moon is gone. No explosion. No warning. No strange light. It simply vanished. At first, most people wouldn't even realize anything had happened. But within hours, scientists around the world would begin noticing something terrifying. The oceans are behaving differently. Animals are becoming confused. And Earth itself has lost one of the most important objects in its history. But here's the strange part. The disappearance of the moon would not immediately destroy Earth. The real danger would come later. Let's say the moon disappears instantly. What happens first? Surprisingly, not much. You wouldn't suddenly fly into space. Earth's gravity would still hold you firmly to the ground. The atmosphere would remain. The oceans wouldn't instantly rise into the sky. And Earth's orbit around the sun would barely change. Why? Because the sun is overwhelmingly more massive than the moon. The moon's gravitational influence on Earth's overall motion is relatively small. But there is one place where we would notice the difference almost immediately. The oceans. Because the moon is the main driver of Earth's tides. And without it, the tides would become much weaker. Not zero, because the sun also creates tides. But they would be dramatically reduced. And that would be only the beginning. For billions of years, Earth's oceans have been pulled back and forth by the gravity of the moon. Every day, coastlines rise and fall. Marine ecosystems have evolved around this rhythm. But suddenly, the lunar tide is gone. Coastal regions that normally experience powerful tidal movements would see a major change. Some tidal ecosystems could collapse. Creatures that depend on tidal pools could lose their environment. Sediment would move differently, and coastal food chains would begin changing. But there's something even more fascinating. The moon doesn't just move Earth's oceans. It also affects life. Many marine animals use the lunar cycle as a biological clock. Some species time reproduction with the phases of the moon. Others use moonlight to navigate. And some predators and prey have evolved their behavior around lunar brightness. Now imagine their world going dark. There's another change humans would notice almost immediately. Nighttime. Without the moon, nights would become significantly darker. Of course, cities would still glow. Streetlights would still work. But outside urban areas, the difference would be enormous. Imagine standing in a remote desert. No city lights. No moon. Only stars. The Milky Way would appear dramatically brighter against the completely moonless sky. For astronomers, this would actually create a strange advantage. Some observations would become easier because there would be no bright moonlight washing out faint objects. But for animals, the darkness could completely change their behavior. Nocturnal predators would lose a major source of natural light. Prey animals could behave differently. Migrating species that use celestial cues could be affected. And humans? We would probably adapt quickly. But Earth itself would not. Because the moon has been doing something far more important than illuminating our nights. It's been helping stabilize our planet. Here's where things become much more serious. The moon helps stabilize the tilt of Earth's rotational axis. Right now, Earth is tilted by about 23.5 degrees. That tilt gives us our seasons. Summer, winter, spring, autumn. But without the moon's stabilizing influence, Earth's axial tilt could become much less stable over extremely long periods. Not tomorrow. Not next year. Not even next century. We're talking about geological timescales. But over millions of years, Earth's tilt could change much more dramatically. And if the tilt changes, the climate changes with it. Imagine a world where the poles receive far more sunlight, or where certain regions experience extreme seasonal conditions. Entire ecosystems could be forced to migrate. Ice sheets could grow or disappear. Climate zones could shift across continents. The moon isn't just something hanging in our sky. It has been quietly helping keep Earth's long-term climate system relatively stable. Now let's clear up one popular misconception. If the moon disappeared, Earth would not suddenly stop spinning. The moon does affect Earth's rotation. Its tidal forces have been slowing Earth's spin over extremely long periods. That's why Earth's day is very slowly getting longer. But if the moon vanished tomorrow, you wouldn't suddenly experience a 48-hour day. Earth would continue rotating almost exactly as before. There would be no instant gravitational catastrophe. No people thrown into the atmosphere. No oceans flying across continents. The immediate aftermath would actually be surprisingly calm. And that's what makes this scenario so interesting. The moon's disappearance wouldn't be an instant apocalypse. It would be a slow-motion planetary transformation. Now go millions of years into the future. Earth is still here. Humans may still exist. But the planet could look very different. The biggest changes would happen gradually. Marine ecosystems would evolve around weaker tides. Animals would adapt to a permanently darker night sky. Species that depend on lunar cycles could disappear or evolve new biological rhythms. And Earth's climate could experience larger long-term variations because the stabilizing effect of the moon would be gone. But there is another consequence, one that is almost impossible to predict: evolution itself. The moon has been influencing Earth's environment for billions of years. Tides created constantly changing coastal environments. Those environments helped shape biological evolution. So if the moon had never existed, Earth's history might have been completely different. Maybe complex life would still evolve. Maybe it would evolve along an entirely different path. And maybe humans would never appear at all. But here's the most unsettling thought. If the moon suddenly vanished tonight, you probably wouldn't feel anything. You could walk outside, drive your car, go to work tomorrow, eat breakfast, go to sleep. The world would look almost normal. And that's the terrifying part. Some planetary disasters announce themselves immediately. An asteroid impact, a supervolcano, a giant earthquake. But the disappearance of the moon would be different. It would be almost silent. The consequences would unfold slowly. Across oceans, across ecosystems, across climates, and across generations. Human civilization might survive the first day, the first year, perhaps even thousands of years. But the Earth we know today would slowly become something else. For thousands of years, humans have looked at the moon and imagined it was simply a beautiful object in the sky, a light for travelers, a symbol in stories, a marker of time. But the moon was never just decoration. It has been pulling our oceans, influencing life, stabilizing Earth's tilt, and quietly shaping the planet beneath our feet. We rarely appreciate the things that keep our world stable, until we imagine them disappearing. So if you look at the moon tonight, remember this: that pale object hanging above you isn't just lighting up the darkness. It's part of the machinery that helped create the world you know. And without it, Earth would still exist, but it would never be quite the same. Sometimes, the things holding our world together are the things we barely notice. And perhaps, that's exactly what makes the moon so extraordinary. Science that makes you question everything.